Okay guys, I think in this video we'll talk about another important characteristic of stack called as LIFO. Okay, so what do you mean by LIFO or LIFO? It is last in first out. Okay, so stack follows this principle guys, last in first out. Okay, so what do you mean by this phrase last in first out? Which it means that the element which you have pushed last, the element which you have pushed at last, okay, pushed last will be the first element which will be popped. Okay, so the element which you push last will be the first element which will be popped. Okay, let's take an example. Okay, so let's say, okay, first I am pushing say 10. Okay, so I am pushing 10, then I'll push 20, so I'll push 20, then I'll push 30. Okay, so I'll push 30, and don't forget that now top points to 30. Okay, top variable. Okay, now understand that I am pushing 10, 20, 30, right? So what is the last element that I have pushed? That is 30. Okay, 30 is the last element that I have pushed because my top also points to 30. So that is the top element or the last element that I have pushed. Okay, so now I'll say pop an element from the stack. I told you that you can only push and pop only from this side, you can't do from this side. Okay, so if I call pop function, if I call pop now, what will be popped? 30 will be popped first. Okay, but I have inserted 30 at last. I have first inserted 10 only. Okay, so this is called as LIFO guys, which means that the last element which is inserted, in this case it's 30, that's the last element which is inserted, will be the first element to go out whenever you call pop, because you can't delete an element from this this side guys. This side is shielded. Okay, so if I say I'm deleting wait a minute, if I say I'm deleting 10, it's wrong. Okay, so you can always delete only the top element. Okay, after that now top will point to this element. After that, if you call pop once more, then you can delete 20. Okay, so this is possible actually. Fine. Okay, super. So understand LIFO structure, the last element will be the first to delete. Okay, based on this, let's have some applications on stack guys. Okay, so the applications would be your undo function in your browsers or Word. Okay, Microsoft Office Word. Okay, so in those softwares you have an super functionality called as undo. What will you do in undo? In undo functionality, you will be having if you do something, then it will be undo. Okay, so, undone. Okay, it will be undone. If you click undo, or if you go for undo, and particular activity will be undone. For example, okay, I'm using that activity here. Let me say, okay, so let me write 1 2 3 4 5. Okay, so I've written 5 numbers here guys. I've written 5 numbers here. Okay, let me click the undo button here. I have a undo button in the screen itself. Let me click that. I'll check what happens. So first, if I click undo button, okay, I think I have to draw that in a single stroke to make you understand. So let me say A, B, a single stroke guys, C and D. Okay, so now if I click undo button, D will be gone. If I click undo button again, C will be gone. If I click undo button again, B will be gone. But if I click undo button again, A will also be gone, which means that I have written only in this fashion guys. A first, B next, C, then D only. But if I the moment I press undo button, the last element which I have inserted is getting deleted. Okay, so the last activity done will be the first to go out, right? So the last activity done will be the first to go out, and this principle is called as LIFO guys. It has a lot of applications, and so stack uses this principle. Understand? I hope I have made it clear. So if I have written something, the last activity, which is my D, which will go out when I press undo, then C, then B, then A. Okay, so this is the idea of having LIFO in stacks. Okay guys, so in our next lectures we'll implement some algorithms in stacks. Okay, thanks a lot. Okay guys, so in this video let's talk about two important conditions called as stack overflow and stack underflow. Okay, so stack overflow and stack underflow, you might have heard about the wonderful website Stack Overflow. It's a good portal actually, but here let's talk about the technical descriptions. Stack overflow and stack underflow, very important terms. So as far as stacks are considered, there are three most important terminologies called as push, then pop and top, right? So top is a variable which points to the top element, push is something when you insert, and pop is something when you remove. Okay, so these three are the basic terms that you must know when you talk about stacks. Other than these, you have two important conditions in stacks. One is stack overflow and stack underflow. Okay, and a stack overflow condition means that the stack is full and you can't push any elements into it. Okay, the stack is already full and you can't push any element into that. If that is the case, then you have to say that the stack is overflowed, or this condition is called as stack overflow. Okay, the stack is full and you can't push anything. So whenever you are implementing the push algorithm, you have to check this condition whether the stack is overflow or not. Okay, if the stack is overflow, then you can't insert any element, guys. You can't push any element to it. That's the meaning of it. The stack is underflow, which means that the stack is empty and you can't pop anything from it. Okay, pop means removal, right? So you can't remove anything from it. The stack is empty. Okay, so that's the meaning of stack underflow. Okay, let's take an example, guys. Okay, so let's say this is my stack. Okay, let me go for some other example. I'll say 1000, I'll say 100, 200, 300, guys. So I have pushed 100, 200 and 300, guys. Okay, so I'll write the algorithm like this: push 100, 200, then 300. Okay, so the last element which I have pushed will be the top element in the stack, guys. Okay, super. And always have the T, it's a good practice. Okay, the top. Okay, the stack will not exist without this top. I told you that so many times. Okay, so after that, let me say I want to push one more element, guys. 400. Is it possible? Of course it is possible. There isn't one empty element here, so I'll say 400. And okay, I'm sorry, guys, my top will now point to 400, right? So yeah, okay, so I want to push one more element, guys, say 500. Is it possible now? Okay, it is not possible, right? Because the stack is already full, and this condition is called as stack overflow. Okay, so if this condition occurs and the user is still wishing us to push 500, means you have to print a condition called as stack overflow, and you can't insert any elements to it. That's the concept of stack overflow, guys. And let me say I want to pop elements now. Okay, I had 400, right? So let me have 400, let me pop it properly. Okay, I'll call the pop function 1. I told you that you should not pass 400 here. It is not correct. Whenever I call the pop function, it means that I have to remove the top element, because that's the only possible case, right? You can only remove the top element. Okay, so call pop once, it will remove 400. Okay, then call pop again, it will remove 300, because now top points to 300, guys. Okay, so now what is the status of top variable? I have removed 300 also, so it will point to 200. Now I'll call pop once again, it will now remove 200 also. Okay, 200 will also be removed, and yeah, now top will point to the last element, guys. And if I call pop once again, then it will remove that element also. Okay, so now top will become -1. Okay, because the stack is empty, so top will become -1 because it's not having any value to point, right? So top will now become -1. I told you initial value of top is -1. Of course, when the stack is empty, the value again becomes -1. Okay, now if I call the pop again, observe that if I call pop again, is it possible to remove any element from the stack? Because the stack is already empty, we have removed all the elements, so it is not possible to remove any other elements. So therefore this condition is called as underflow condition. Okay, stack underflow. Okay, and this condition can be easily checked by checking whether t equals to -1. If top variable equals to -1, this means that the stack is empty, right? Then you can easily print that the stack is underflow. What I'm trying to say is, you can just write a condition like this: if top equals t equals to -1, then you can print a message, printf a message, stack underflow. Okay, so this is the message I wish to tell. So okay, we'll implement this algorithm in the next video. In the very next video, we'll try to implement this push and pop, and I'll also tell you how to create a stack first. Okay, thanks a lot.